Good afternoon. I'm Calum, part of the Earth observation team at Astrosat, and I'm going to take you through eXude after a very brief introduction to Astrosat for those who aren't familiar with us. So we're a commercial space services company based up in Edinburgh. Most of our focus up till now has been on satellite applications in a number of different areas, including floods, forestry, marine environment, so similar to earlier on the chlorophyll, algal blooms, things like that. Coastal erosion and subsistence are some of the areas we've been working on. We also have a flagship project under IPSP called Rapid, Recovery and Protection in Disaster, which some of the eXude stuff has been gradually dripping into. And we use this kind of observe, orient, deliver and act as our kind of ethos we approach all our projects with. In terms of eXude, the main goal of eXude was to enhance current flood delineation methods, and the idea to try and move towards methods that we could use perhaps in the urban environment from space. So from the flood delineation point of view, most flood delineation uses SAR and uses single polarization SAR. We were looking at multipolarization SAR and how we can use the enhanced amount of information available in that data to give us a much more accurate flood delineation. And we also looked at the potential for radar altimetry for flood water height. We had a wee introduction to radar altimetry earlier in the day. The other side of it as well was how we can actually provide useful information to the end user. So the end user isn't just interested in data, they want actionable information quickly to hand so they can make decisions based on that. So we looked at how we could integrate other data sets to make our information from the satellite data more usable. So first off, in terms of satellite altimeter, for the altimetry, we looked at the different satellites that were available. There's two modes that they generally operate. There's low rate mode and delayed Doppler altimetry mode. Most operate in low rate mode. Only one satellite that's operational right now operates in DDA. Which is Cryosat, but only operates in the polar regions. The advantage of DDA is that it gives you an increased long track resolution. So we were working just with the LRM sort of data, and we used JSON2 as our satellite for trying out different case studies. So here we show you a case study of Hamburg. In 2013, they had a sort of storm surge flood that came up the river there. And you can see the sort of data that comes from the altimeter. This area here is around the Docklands in Hamburg, and you can see there's a lot of noise here. So this is the real challenge when using altimetry data and analysing it in urban environments, because it's mainly being used for sea surface heights and for analysing polar ice caps. So we applied various retracking algorithms to the data, and the sort of output here is shown over the top of SRTM DEM data, so digital elevation model. The dots there are our output from the altimeter data. So it tracks reasonable across the urban environment. This noise here, though, gives us a huge amount of uncertainty in our outputs here. So although you can see there's a difference, which we would expect from the flooding water in terms of your heights, the amount of noise means we're just a bit uncertain as to the accuracy of this data in its current state. But it does show there's good signs for actually spending time to produce retracking algorithms that are targeted specifically at this area. For the SAR, the multipolarization SAR, we use data from all the operational satellites that provide quad polarization data. So most of your operational satellites just use single polarization. Sentinel-1, which most of you are familiar with, gives you dual polarization. We're using data from RadarSat-2, TerraSAR TandemX combo, and also ALOS-2. So this was an interesting example here over Vancouver. So we just got Landsat-8 just to give you an example of where we're looking at. So there's the airport in Vancouver and some of the water you've got going around it. So we applied polarimetry techniques to the data and then classification algorithms in order to get the outputs you see on the screen here. The middle one was really interesting because we thought, eureka, we've got information that's going to be useful. You can see there's a distinct difference between the water and the airport here. And one of the biggest issues when using the backscattering information from the radar is that smooth surfaces like tarmac, concrete, so roads, look very similar to smooth surfaces like water in terms of backscattering. And the more often than not, you end up with classifications like this, where you've got the water and the airfield appearing very similar. So this was a bit of an anomaly. It turns out on this day there was a lovely northwesterly breeze, which was creating a lot of chop in the water, which gives you the kind of difference between the water and the airfield. And more of our classifications were like this one on the right from the different data. So we looked at other locations like Vietnam and other urban environments in Europe as well. So what we did discover, though, is that although we can't use it for the sort of delineation in an urban environment as we aim to do, there are a lot of improvements you can provide by using either dual or quad in terms of doing your general flood delineation. So there are benefits in looking at this, particularly with all the free data, open data we've got coming from Sentinel-1 in terms of improving on delineations you're doing at the moment. And finally, the kind of other side we're looking at is assimilating other sort of data. So we've gone back to the UK here, and using the Somerset levels. Sort of all the open data sets we're getting now from the EA and through the Open Government License are fantastic for doing these kind of analysis. So here we've got flood depths, so we've got flood extent from SAR, and then we've used LiDAR data that recently became open to do our flood depth estimations. And then we've also got the orange lines, which show flood defences, again an Environment Agency data set. And this is useful to kind of see how a flood progresses over time and the impact flood defences have on that water movement. Is it causing the flood to sort of change when you put in a different flood defence, compare a previous flood from a year, 2 years ago, something like that, in order to show how the defences are having a long-term impact? Has it caused the flood to move perhaps to a different area? So giving you a bit more of a catchment-wide assessment of the flood impact. This one here is just showing you the sort of information that can be interrogated from the flood defences, so you can look at things like their height. So is that flood defence still blocking the flood depth that you'd expect it to, or has it degraded and no longer able to prevent that? And also we're showing kind of volume change, so quite a good way of assessing actually how the flood has changed over the time series of a flood event. Where is it building up, where is it reducing in terms of how you're managing that water flow. In terms of end user engagement, we've engaged with a number of different public sector organisations. One of the recent ones we've been talking to is Historic Environment Scotland, who came to us with a problem in that they've got a lot of buildings in exposed sites to floods, coastal erosion and things, and they're a bit concerned about the impact that more and more sort of environmental events are having on these properties. So we're hoping to continue working with them, looking at how we can assess the aftermath of a flood event as well and what impact it has on the property. CFAS we kind of got in touch with recently on a number of areas. We're really interested in working with them. This sort of SSGP project has helped boost those relationships and potentially look at moving towards coastal flooding problems as well with that. SEPA, we're hoping to get down very soon to speak to us and see what we're doing. We've been speaking to them about the data they're gathering on the ground and how we could help enhance what we're doing with that ground data towards validation, things like that, and how the satellite data could enhance their flood monitoring efforts. And the M&O has generally been very useful for us in terms of getting into contact with different organisations. Perhaps it's not specifically in their remit, but they put us in touch with a lot of different public bodies as well. We've also been looking at the sort of private sector a wee bit. I mentioned RAPID earlier on in the presentation, and that's mainly targeted at the Association of Southeastern Asia Nations. And although the sort of flood monitoring stuff we're doing with them is a little bit more primitive than what we've been talking about here, a lot of the techniques we're developing here are starting to feed outwards towards the sort of international commercial sector as well. In terms of benefits, looking specifically at what we've been applying in this project, the flood defences sort of thing will allow us to manage flood defence a lot more effective over a sort of catchment area, looking at what sort of impact new defences have, You can also sort of update as you put in emergency defences and look at how you can optimise your sort of new solutions by having that time series. One of the important things we'd like to do is make sure that flood monitoring continues beyond the event as well. It's important to assess the aftermath of an event in terms of how you're going to plan for the kind of future rather than being reactive, a lot more proactive about future events. Social kind of impacts, all pretty obvious. If we can improve on flood sort of monitoring and defence situations, then it's going to have impacts for property, people and resources, improving their situation, reducing the number of severely damaged properties, people relocated, etc. The financial thing, we see that by using this sort of tool, you're able to manage your efficiency of investment a lot better, make sure you're spending things in the right place, and we anticipate that the solution that I'll describe in a second, the business model, will give you a sort of low cost in terms of the damage recuperation you have, so how much you've saved from less property damage. In terms of business model, we envision it being kind of a service-based business model over the long term. As I say, one of the important things we think is that you want to be monitoring the aftermath of the flood event. So the cost, though, will mainly be incurred around the event, and we generally sort of estimate around 10 scans per major event, and that's where we're sort of estimating the majority of the costs coming from, including the processing, etc. You can see some figures there on the sort of impact of flood events. And we reckon it would be sort of, if you were able to save 10 to 20 properties, that would cover the cost for one event in terms of your amount of scans being required. So next steps moving forward, we began preparation for the phase 2 proposal that we got in the sort of email last week. So we're currently contacting a number of end users, and we're going to sit down and focus on what their actual needs are moving forward to make sure that we've got a partner on board who can really work with us in terms of making sure this product comes to a usable state, which leads on to a kind of real-world demo, hopefully bringing in some validation techniques such as we were talking about with SEPA. Post-impact analysis as well. Be really keen to bring in other data types, again thinking to the historic environment in Scotland, looking at the after impact, say with a Sentinel-2 image, you can see how the land has changed from the flood event. And again, coming back, you can see a wee snapshot of our portal that we've got for Rapid. And again, using the same sort of tools, we could create our own eXude portal as well for deploying these in an actual usable way. So just to sum up, we kind of reached for the stars a little bit with the project in terms of trying to target urban floods. We did land on the moon, I would say, and we have come up with techniques that are going to be usable and enhancing current flood monitoring methods. There is a bit of a technology gap in terms of making some of these methods fully operational, so things like the altimeter stuff, constellation size aren't really there for using it for an operational tool. SAR, things like that. If we go to using just dual polarization rather than the quad, then it opens up constellations like Cosmos SkyMed, which has the 4 satellites, so that gives you much better repeat times. Overall, though, increasing the amount of data usage, the information we're gathering from that data, so the multipolarization rather than single polarization, has given us a better output. And in general, we think extending the coverage and having that post-flood event analysis will be very useful too. Thank you for listening. There's no question slide there.
So are there any questions for Calum about his project at all? No? Congratulations.
Sure.
Thanks.